Okay, good. So 5.2, okay, we talk about scientific notation, okay? So first, does anyone of you know what is one Google? Okay, you know the search engine Google is actually named after this, Google. It's supposed to be spelled like this, but then later on, because they couldn't use this word, they had to choose the other spelling. Okay, so Google, okay? Now, one Google, let me tell you the story, okay? One Google, one day, this mathematician, okay, he wrote down this number, 1 followed by 100. So I say, well, this will be a very nice number. Let's give it a name, okay? So, and he asked his nephew, who's about maybe 1 or 2 years old, and then the nephew say, Google, okay? So it's let's just name this Google, okay? So that's how it comes from, okay, Google, okay? Now, one Google, this number here is so large. To give you an idea of how large this number is, this is actually more than, if you count the number of cents on Earth, okay? So it is more than the number of sand, S-A-N-D, sand, okay, on Earth. And then they say it's also more than the number of stars in the universe. So a lot of you say, oh, you want to be a millionaire, a billionaire, and if you are a good Googlean, okay, so you have no place to put your money, okay. So that's so, yeah, this is a very large number, okay. Now this number here, if you write 100 after that, that will be very tiring, right? You take the whole page, whole chalkboard to write it. I used to have a student who tried to write 100 there. So, and sometimes you might miscount, right? Okay. Now, a better way to represent this number is using scientific notation, okay? In scientific notation, this number is represented as 1 times 10 to the what power, you think? 100, okay? 100 power. Then this is going to be 1, and then after that, you have 100 after that, okay? So this is the scientific notation for one Google, okay? So what is a scientific notation? Basically, it consists of 2 parts. The first part over here will be a number that is greater than or equal to 1 and less than 10, okay? So, and then the second part over here will be 10 to some integer exponent. Remember integer, they are 0, plus or minus 1, plus or minus 2, etc. Those are called integer, okay? So this first part over here will have 1 non-zero digit in front of the decimal point, okay? So it has to be, it will be a non-zero digit. So it will be 1, 2, 3, 4, 5, all the way to 9, etc. Okay. And then after the decimal point, you can have as many digits as you want. Okay. Depends on what that number is. Okay. So this number here is greater than or equal to 1, less than 10. Okay. Okay. Now let's practice to convert a number from standard notation to scientific notation. So the first one over here, it is this one. Okay, this is, what's this number? It is 1,500,000,000, okay? So that's in standard notation. This is how we normally write the number, okay? Now, in scientific notation, in this form, so how should we write this? Remember, the number, the first part here, you will have this number is between 1 and 10. You will have 1 non-zero digit before the decimal point. In order to have 1 non-zero digit before decimal point, so you go from left to right, the first non-zero digit is this 1.
Oh, just 1.
So, yeah, so you will put the decimal point right after the 1. Right?
Okay.
Okay. And so you have this first non-zero digit 1, and then we put the decimal point right after this one. So you have this 1.5, okay? And then times 10 to some exponent. Now, let's think about this. The decimal point used to be over here, right? Now, you move the decimal point how many places to get to that? 1, 3, 6,
9.
9. Yes, you got it. So you move the decimal point 9 places from here to here, okay? So now you get this 1.5. So this one here will be times 10 to the
9th.
9 power,
Mm-hmm.
10 to the 9 power, okay? So you just need to count how many places you move over here, okay? And this is 9. So this is a large number, okay? For this kind of large number over here, this is a large number. When I say it's a large number, I mean it is actually greater than, if it's greater than 10, okay? So if it's greater than 10, then this one over here, notice that this is a positive exponent over here. Okay, positive integer exponent over here, positive 9, okay? Now the second one over here, this is 0.00025. It is a tiny number, okay? So it's small, okay? When I say small, I mean that it is greater than 0 and less than 1, okay? A tiny number, okay? So this is the tiny number, a small number. This could be maybe the diameter of a virus in millimeter, etc. Okay, so it's very small. Okay, now to represent this kind of a small number, we also use scientific notation. Okay, so when you go from left to right, the first digit that you encounter over here, it is this 2. And then you're going to put the decimal point right after the 2 over here. So you have 2.5. Okay. Times 10 to some integer exponent. Now let's try to figure out what integer I should put here as the exponent for this 10.
Isn't it -5?
Yes.
If 4.
Let's count. Okay. So you go 1, 2, 3, 4. 4
Oh,
places.
4. Okay.
Yeah. So we go 4 places. So it used to be over here. Now you move 4 places to get to this.
Okay, I
So
see.
it is 4. However, it is a small, tiny number, so it is a negative. Okay, so -4. Okay, so if it's a tiny number over here, then you will have this. So if it's a tiny number, okay, then you have this negative exponent. Okay, right here. So it's -4. Okay. Question?
Miss Renee, I have a question.
Sure.
When you said large greater than 10,
Mm-hmm.
to make it positive, I didn't get that part.
Yeah. So if it's not greater than 10, like this number over here is greater than 10, then you have this positive exponent. Because, okay, let me give you another example. So for example, like 18, okay, say this 18 here, it is greater than 10, right? Okay, or maybe you can put 12, okay? So it's greater than 10. So to represent this using scientific notation, so the first non-zero digit I encounter here, it is 1 over here. And then I put the decimal point right after this non-zero digit. So I will have this 1.8. Okay. And then times 10 to some power. Okay. Now, the decimal point used to be after this 8, right? Now you have to move 1 place to get to this 1.8. So we will 10 to the first power. And the first power. And you see this one over here, it is a positive. It's a positive exponent on that, on the 10. Okay. So any number that is greater than 10, then even including 10, actually I should say also including 10, greater than or equal to 10. So for example, if it's 10, then this one you can use it as 1, but then times 10 to the what power? First power, right?
1.
Yeah. So it's actually when it's large, greater than or equal to 10, then the exponent over here on this 10 here will be positive. Okay, so positive 1, positive 2, etc. Okay.
Okay, so when it's greater or equal than 10, the exponent is going to be positive?
Yeah, the exponent here will be positive. Yeah.
Okay, great. Thank you so much.
Okay, no problem. I'm glad that you asked. All right. Now, what about, and then you might ask, what about between 1 and 10? Okay, between 1 and 10, say 9.28. Okay, so how can you represent this using scientific notation? Well, this number over here, it is between 1 and 10. It is already certified that, remember the first part of the scientific notation was is a number between 1 and 10, right?
Right.
So this will be just right. So you have 9.28, just the number itself, okay? And then times 10, if you really want to represent it in scientific notation, then you have to times 10 to the what power? Guess what power would that be? 0 power, yes, 0 power. Remember last time we talked about 10 to 0 power, it is what?
1.
Yes, you got it. Okay, 10 to 0 power here, it is 1. Okay, so last time we talked about any non-zero quantity A raised to the 0 exponent, raised to 0 power, that's equal to 1. Okay, that was for any non-zero A. Okay, so that was what we have last time. Okay, all right, so that will cover all 3 cases. If it's greater than or equal to 10, you have this positive integer exponent. If it's between 0 and 1, you have this negative exponent on this 10. If it's between 1 and 10, then you will have this 0 exponent on the 10 right here. You got it?
Yes.
Okay, that's great. Okay. Now the next one, okay? This one here is not a scientific notation. Can someone tell me why this is not a scientific notation?
It's not a number
the
between
number
1 and 10.
Yes, the first part over here, right, is not a number between 1 and 10, right? Okay, good. I think I got it. Okay, so this one over here, this is not between 1 and 10. Okay, so that is not a scientific notation. Okay, so the way that we can write this is we can try to, okay. So to make it scientific notation, so what should we do? You put the decimal point after the first non-zero digit, which is after the 4 over here. So you have 4.762. Okay. Now times 10 to the what exponent?
10 to the third.
Okay. So okay. Let's find out. Okay. Now some of you, if some people can do it in one step, but let's start from step by step. Okay. So let's break it down. So first, you can try to think about this. This one over here, in order to write it as 4.768, if you have the decimal point here, you need to move 2 places, right? So that number over here, it is 4.762 times 10 to the second power. Okay, so for this one, that part right here. Okay, now, right now, we are multiplying this by 10 to the 8th power. Okay, then what happened over here is 10 to the second times 10 to the 8. These two can combine, right? So remember this, the product rule for those, right? So when they're side by side and multiply and they have the same base, you keep the base and you add the exponent. So you will have the 10 because this is 2 plus 8. Okay, make 10. Okay, so over here, the exponent over here is 10. Now in the future, you can try to think about it. If I move it from here to here, I go 2 places to make it smaller. Then I have to increase this exponent here by 2. Okay, increase that by 2, so I get 10. Okay, got it? Question? You guys good? Give me a thumbs up if you guys are good. Now the second one over here, the next part over here will be convert back, okay, from scientific notation to standard notation. Okay, 5.123 times 10 to the 4 power. So now let's think about 10 to the 4 power. 10 to the 4 power, it is this number 1 followed by 4 zero, right? Is 10,000, right? Okay, it is a large number, right? Okay, it's large. So when this number times a large number, right, it's going to make the product, make the result to be larger than this one that you start with, right? Okay, so you're going to move the decimal point to the left or to the right to make the number larger.
To the right?
To the right, yeah. So we have 5.123. Now we're going to move the decimal point to the right 4 places to make it larger, right? Times 10,000, it's going to move the decimal point 4 places to the right, okay? So right 4 places to make it larger. Now over here, now the new decimal point will be over here, okay? And then you fill in this 0 over here, okay? It's kind of like the basket, like the Easter basket. You put the 8 over here, put the 8 inside here, okay? So the new number that you got will be 51230. Okay. So that is the result, okay? Now, what about this one? This one over here is 10 times 10 to the negative second power. 10 to the negative second power, remember we talked about negative exponent. So this is the negative exponent indicate you're taking reciprocal, right? So it's 1 over what? 10 to the what? 10 to the second. You got it. Good job. 10 to the second. Okay. Now that is the same as 1 over 100, which is the same as 0.01. Okay. So which is a tiny number, right? It is a tiny number. When I say between 0 and 1, I consider as tiny. Okay. So when this number multiplied by this tiny number, it's going to make the result smaller than this one that you start with, right? Okay. So I'm going to move the decimal point. So you have 2.38 before. So to make the result to be smaller, you move the decimal point to the left or to the right?
To the left.
To the left. Okay. So you move it to the left 2 places because this is 2. Okay. So move it 2 places, 1, 2. So the new decimal point will be over here. Now you fill in the 0 here, right here. Okay. So to the left, 2 places. Okay. Now the result here will be 10238. Okay. So that is the number we got. Okay. So positive exponent over here, you move the decimal point to the right. Negative exponent here, you move the decimal point to the left. Okay.
Now let's take a break.